This tutorial is on one of the three analytical methods for network analysts that we'll be reviewing, and it is the root. So root answers very simple questions. How do I get from one point to another? It can also answer the question, if we had multiple, right, how do I get the best route to touch all of those points? I'll leave that to you if you want to explore that on your own. I'll show you the mechanisms of how you set something up. But for start, we're just going to do A to B. Like anything in ArcGIS, hundreds of different pathways to get somewhere. You could find this here in our toolbox under the Network Analyst. You could search for it. But again, I love those right clicks. And if you right click, you'll find the Network Analyst mini toolbar here, right? Kind of comes up, has everything designed for you. We'll get into everything over here in a little bit. Most important is it's telling you the active network data set. So right, perhaps you have multiple that you want to do. One that's bike specific, one that's for roads, one that's for different cities. Right? We only have one, and that's our active one. Over here is where you actually pick the analytic method. Right? So today we're only going to review route, service area, and closest facility. These are more complex and very, very neat. An OD cost metrics is kind of similar to closest facility, except it doesn't generate the actual lines, or sorry, the actual routes you would take. It calculates those routes, but its output is a series of lines connecting routes to destinations, right? So it's a time-saving device. Vehicle routing answers the problem, if Shay runs a bakery and he delivers all over the city and I have 3 trucks and 3 drivers that live in 3 different areas, how can I determine who should deliver to where and at what time? And location allocation is essentially how you can connect supply to demand, right? So if I have a business and I know who the people to whom I'm trying to sell, how do I locate a facility that has the best connections to my consumers? So route will be the first one. So you notice anytime you click on something, you get one thing that appears in the layer window that essentially is just a summary of anything that you might create. To be able to proceed, though, you're going to want to click on the Network Analyst window, right? So these two need to work in congress. This essentially is kind of where I'm storing the data, or what it's going to look like. This is how I set things up, right? So stops, I have to figure out what my stops are. Kind of similar to everything else, you can find addresses and make it, right? You can open the attribute table when it's really there. But if you want to get this started, you go to load locations. So I got my load locations toolbar here. What do I want to load? Well, right now it's route points, right? Sort field, essentially if you have something stored within your route that determines which one should go to first. If you don't, it's just going to default to what the FID is. But right, let's say you have multiple points and you want to get from A, B, C, D, E, G, right? Maybe store those in the attribute table, and then you can tell it that's how you want to sort it. Some of this stuff is not really what we're going to focus. We'll just kind of tell you if there's a field that has like a time window, right? If you've attached time to your network data set, but we haven't. So all of these things are more for your advanced user. Use geometry is the only other interesting thing. Like if I had a facility here, I wouldn't want to necessarily preclude it from analysis. So I set a search tolerance. So it looks outside of itself for 5,000 meters and snaps it as close as it can possibly get, even if it's sitting out here. Very good. My locations are loaded. I'm going from 1 to 2. So the final thing I need to do is open this little window here, right? So it's a little step here. Find what you want to do, you engage the Network Analyst window, and then you engage the properties. All right, so what it is, what's involved in it, what's the properties, and very important, what is the analysis settings? Right, so we kind of created 3. I want to start with length. Notice here I have the ability to turn restrictions on and off at will, right? If I cared about one way, like I'm a driver, maybe I'll leave it on, but if I'm just thinking walking and you can walk anywhere, I could turn it off. You can allow yourself to calculate time attributes and directions, but for right now I want to leave it solely at length. And you can also use a start time, right? If you're taking information from ArcGIS Online, or you have some kind of time attribute that you've set in the field, you can use that as a function. Allow yourself to use G-turns, if there's invalid locations, or sorry, U-turns, not a G-turn. You'd ignore it. Accumulation is if you want to add something else in the attribute table, right? Like maybe number of Burger Kings you passed, if that was a cost that you had. just kind of running over your parameters. And network locations just where's everything sort of located that you're going to and from. But really the important stuff is the analysis. And important in this is that we're calculating it in feet. So I'll hit OK. And right here I hit solve. And there we go. It has calculated the path of least resistance to minimize my distance between 1 and 2. I can take a look at this route and see it's about 21,916 feet. Right? So it is about a little over 3 or 4, oh, just under 4 miles. Now, remember we did all that stuff where we looked at also kind of time, right? I mean, I would imagine I could just get on this highway, and if there's not traffic, I could probably get there a lot quicker than taking these back roads, based on how fast you can go on highways and such. So why don't we try to do that instead? I'll pick travel time. Hit OK. And now if I solve it, look at that. That is the route that I would take to get there quickest by travel time. And remember, we made travel time an attribute by converting the miles per hour to feet per minute and then dividing how long a road is by feet per minute, right? So if I can travel 500 feet per minute and my road is 250 feet long, then it takes me half a minute, right, to get on that road. So a little while ago I created a crime layer, something that we're going to learn how to do in future lessons. Right? So I took where there's violent crimes and burglaries and created a density map so we can see the areas that are really concentrated, moderately concentrated, and less concentrated. Let's say I'm terrified, right? And just for a way of comparison here, let's recalculate it based on length. Right, so I'm terrified, and for me, I'm willing to trade a little bit of distance if it keeps me away from crime in this instance. But you can imagine this could be any number of things: hills, green space, right? Anything I might want to factor that is different than distance but is normalized by distance. And this is where I'm starting to talk about cost being somewhat of an abstract thing, right? So what we're going to do now is kind of ask that question: how much distance would I be willing to trade, right, if I could avoid crimes? Now, I already prepared this data in such a way that all of the roads know exactly their crime density, and then from there I was able to do a quick analysis to determine what was relatively high and low, and that was the crime cost you saw me make earlier. Right, so crime cost was nothing more complicated or complex than taking each road's length and kind of giving it an additional multiplier if it passes through a zone of high crime. Right? So high crime, high crime, high crime. So again, this is the shortest distance, but maybe I'm going to trade a little bit of distance if I can avoid the high crime pockets. So it's not a science, it's more of an art once you move away from distance and time and into the realm of cost.